I was saying, maybe I should go through one example of calculation of the theoretical yield. Then you can apply that to your final version later of the practical. So let's use the pentyl ethanoate banana smell one as example. Okay. So pentyl ethanoate. Because you guys did pineapple, didn't you? So this is the banana one that no one did. That's why I'm using it as an example. All right, so pentyl ethanoate looks like that. So one of the examples in the equation, pentyl ethanoate. So pent, C. No, ethanoate. That's only 2. Sorry. Okay, the short form there, and you had the reagents there, and if you can see what was used before, so it should be CH3COOH, so that's ethanoic acid, and pentyl, so HO here, and so they were the reactants, yeah? In your prac, how many grams of acetic acid did we use again? Not acetic acid, sorry, carboxylic acid. One was 9 and one was 12. Can't remember. It doesn't really matter. Whichever should be a limiting agent anyway. 12 of alcohol, okay. So this was 9 grams. Right. Okay. Now, depending on what reactant you use, you had to work with the molar mass of them. Yeah. So first thing that you need to do is to calculate the molar mass. So in this example, I've got ethanoic acid. How heavy is it per mole? I might need someone's calculator then. So 12.01 times by 2 plus 16.00 times by 2 plus 1.008 times by 4. And if someone can start doing pentanol, pentane 1O, please. 60.05. 60.05?
Yeah.
Okay. Is anyone doing this one? So 12.01 times by 5 and then
Molar mass.
yeah, molar mass plus 16.00 times by 8, 9, 10, and then 12. So 12 times by 1.008.
What's the carbon?
12.01 times by 5. 88 point.
1.5.
Don't round yet.
Okay, go 146 then.
146. Alright. Now, you need to calculate which is limiting agent first. So you need to convert grams into number of mole. Okay. So this will be mass, and then when we start, you need to find number of moles. number of moles.
So it's 9 over 60.05.
9 over, yep. It should just give you mole. Do you want to carboxylic acid? That's alcohol?
No,
What
this
is
is the
that?
acid.
Acid. Do you know the alcohol? Acid
How
is?
many decimal places?
Just give me the whole number.
0.149875141.
Okay.
Ready?
Yep.
0.136. Do I want me to keep going or?
Yeah. That's fine, actually.
137.
Well, as long as you can tell, yeah, you could keep going, that's alright. As long as you have that on your calculator, you can take smaller number from larger number, yeah? So in this case, which is being limiting agent? Smaller number, okay? So that's being the limiting agent in this case. So by knowing that, you know that that's the number of mole that's available for the reaction. Yeah. Excess amount of that wouldn't react at all. Right? And looking at mole ratio, which is 1 here and 1 here, so same ratio. So theoretically speaking, you should be able to get the same number of mole of this product. Yeah? So how many gram is that? Well, that's something you have to calculate as theoretical mass. You've got molar mass, or you can find the molar mass of that. Number of mole is already here, 0.136, da da da. Now, so use the calculation and don't lose the decimals when you're doing this calculation, right? Can someone do molar mass for this one? I should get the same number of mole here, theoretically.
Or can you get the molar mass?
By looking at the formula, yeah, you should be able to. So carbon wise, 1, 2, 3, 4, 5, 6, 7 times what, 12.01.
Couldn't you
Yeah.
add the two of the reactants together and take the
Take H2O, you can do that too, yeah. So yeah, add those numbers up, take 18.016. Yeah. 132.198. Okay. Now looking at the unit, grams per mole and mole, if you multiply them together, grams should be left here. So if you multiply that by 12 over 88.146, what do you get? Remember you got this 0.136 mole by doing, oh, did that? Yeah, 12, yeah, 12.
Are you using the rounded one or the full number?
Not to, no, you're not using the rounded one. Remember how you calculated this number of mole here?
Yeah.
Yeah, you did 12 by 88, da da da, right? And That was a long decimal number. Because you don't want to lose that, on your calculator you can just use the answer from previous one. But if not, yeah, that times by this whole thing. 17 point. Okay. So this mass is the theoretical. Yeah. Oh, that's what you could get. Yeah, almost 18 grams. So, then what's the percentage of it? So percentage yield could be figured out, kind of like error, but you could just do actual experimental yield over theoretical. So small number, it should be smaller than usual, and then theoretical. So that's the whole number that you were expecting. And if you multiply by 100, you should just get, you know, what was the percentage of the yield you could achieve over what you found. So if your actual value that you found was like 3 point something grams compared to, well, provided you have done this banana smell one, right? You know, what happened? Where did all the esters go? Then you can hopefully relate to the theory where this reaction is actually very slow to go forward. So, yeah, you need to talk about backward reaction. You can talk about equilibrium a bit. What else? Like when you are decanting, there must be some loss. Hope you have some evidence, like photo evidence to talk about it too, even. Just suggesting. If not, well, make sure you talk about it anyway. Yeah.
Do you still have
Your esters?
Yeah.
Yes, I managed to keep 2. One went off, so I had to discard that one.